Here we're going to talk about how to calculate the volume of a rectangular prism. And a rectangular prism essentially is a box. You can just think of it as a box. And when we talk about volume, we're talking about, you can think of it as filling something. So like a swimming pool, you fill it with water. How much water do you need? That's what volume is. Whereas with area, it's more like painting a surface, and perimeter, it's going around the edges. With volume, you're talking about filling something. And when we talk about volume, all of our answers will be in cubic, whatever the metric is. So if it's feet, it'll be cubic feet, inches, it'll be cubic inches. So whenever you see cubic, you are going to be talking about volume. So if you look on your formula sheet, the volume of a rectangular prism is length times width times height. It says LWH, so you need to know length times width times height. So we're going to do a couple of examples. So if you think of, if this is a box, and it is 10 by 7 by 3, we'll say these are feet. So the length, this is the length. W is the width, this is the width. H is the height, this is the height. So you have length, width, and height. All you do is multiply them by each other. So when you see three letters right next to each other, that means multiplication. So what's the volume of this box or this rectangular prism? Volume is the length, which is 10, times the width, which is 7, times the height, which is 3. Get your calculator out, you do the math, you're going to get 210, and this is feet, so it'll be feet cubed, is how you would write that. So essentially these problems are fairly straightforward. It's length times width times height when you're talking about any sort of a box. We'll do some additional problems that will be a little bit more complicated, but this is the basic formula and what it means. So let's say we'll leave the box up there, but just to draw your attention to something. So let's say now they give you a problem and say, okay, you have a swimming pool. It's 25 feet. Well, let's say it's not a swimming pool. Let's say it's a driveway. You're going to pour concrete in a driveway that's 25 feet by 16 feet by 6 inches. So this is drawn out of scale, but it's 25 feet by 16 feet. But the depth of it, remember it's a driveway, is only 6 inches. So how many cubic feet of concrete do you need? So if this is the question, remember, always make sure when they're asking for feet, this is 25 feet, this is 16 feet, but this is 6 inches. Always make sure your units are all the same. So in order to do this, you have to change this 6 inches into feet. So 6 inches into feet, there's 12 inches in a foot, so 6 divided by 12 is 0.5 feet. So here we're going to write 0.5 feet instead of 6 inches. So how do we find the volume of this? Again, it's very simple. The volume is length, which is 25, times width, which is 16, times height, which is 0.5, not 6, because it has to be in feet. All of the units have to be the same. So multiply it by 0.5. Get out your calculator and you do the math, and you're going to get 200 cubic feet is the answer for that problem. So I just do this one to draw your attention on, pay attention to the units that they give you, because this is how they're going to try and trick you. All right, let's say we have some blocks, like blocks that kids play with, and these are cubes, so all the sides are the same, and we'll say that they are 2 inches on each side. So this is just a toy block. It's 2 inches on each side. We're going to put that into a bigger box. So we're going to have a bunch of blocks, and we're going to put them all into a bigger box. Now this box is going to be, we'll say, oops. So we're going to say that this box is going to be 8 inches by 6 inches by 4 inches. So kind of, again, not totally drawn to scale, but this is 8 inches by 6 inches by 4 inches. We're going to take these little blocks and put them in this box. So we're going to fill this box up. So we want to find the volume. We need to know how many of these blocks can we fit in here. And so that is a volume question. Now, we're going to take a break, and I just want to talk to you about thinking logically. So let's say you get to the test, you can't remember anything about volume. Think logically. You don't always have to memorize things and be thinking mathematically. If you just think logically, you would be able to figure this problem out. So it's how many blocks can fit in the toy box. So I'm going to show you how to do this by volume, but first I'm going to show you how to do it logically. So if you have a block is 2 by 2 by 2, so if you look at the bottom of the box, it's 8 inches across. So how many blocks can we get across the bottom of the box? Well, if each one is 2 inches, you can put one here, that's 2 inches, and then 4 inches would be another one, 6 inches, and then 8 inches. So we can get 4 blocks across the bottom. How many can we get across this way? Well, this is 6 inches, so if we put one in there, that's 2 inches. Then we put another one in there, that's 4 inches. And then we put another one in there, that'll take us to 6 inches. So if we look, let's say we're going to look from the top down on this box. So we're looking at the bottom of the box. We're looking down into the toy box. We have 8 inches here, 6 inches here. We can put one block in there. We can put a second block in there. We can put a third block in there. We can put a fourth block in there. We can only get 4 across because each is 2 inches. So 2 inches, 2 inches, 2 inches, 2 inches. By the time we get 4 in there, we have 8 inches full. And here we've gone up 2 inches, because remember each side is 2 inches. Then we can put another one here, another one, another one, another one. So we've gone another 2 inches. So we've gone 4 inches. We have 2 inches left. So we can put another one. This isn't drawn to scale. So at the bottom of this box, we can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 blocks at the bottom of the box. So covering the bottom, we can have 12 blocks. We can fit 4 this way and 3 this way. So 4 times 3 is 12, or you can physically just count them all up. So we filled up the bottom of the box. Remember, the height of each block is 2 inches, so we filled up essentially half of the box. Because if it's only 4 inches high and each block comes up 2 inches, we filled up half of it. So we have one layer of 12 blocks. We can put another layer on top because we have 2 more inches up here. So we can put 2 layers of blocks into this box, 12 in each layer. So 12 plus 12, or 12 times 2, we can put 24 blocks in this box. So if we know nothing about volume, you can still figure this out. Just think about it logically. You're going to stick a block in there. It's going to go over 2 inches this way and 2 inches this way. Stick another one in. So I just tell you that just to let you know, don't get scared off by problems if you can't immediately remember what formulas mean or anything. Just try and think about it and you might be able to figure out logically. If we're going to do this by volume, we figure out what's the volume of this larger box. So now I'm just going to purely show you how to do this by volume. So the volume of the larger box, very simple. Length is 8, width is 6, height is 4. You get your calculator out and you do the math and you get 192 cubic inches. That's the whole volume of this box, of the toy box. What's the volume of one of the blocks? The volume of one of the blocks is length is 2, width is 2, height is 2, is 8. So the total volume of the toy box is 192 inches cubed. Don't get really caught up in this right now. The volume of one of the blocks is 8 inches cubed. So how many of these fit into here? You just divide 192 divided by 8. So 192, that's our total volume, divided by the volume of one of the blocks. You get your calculator out and you're going to get 24. So that's the same answer that we got before. This is obviously a little bit easier if you understand volume, because you just have to multiply these three numbers together, multiply these three numbers together, and do a division, and you get the answer that 24 blocks would fit in there. So we first found the volume of the larger box, then we found the volume of one of the blocks, and then divided the volume of the larger box by the volume of one of the blocks, and that's how many would fit. So the answer is 24 blocks fit in the toy box. We'll do one more problem using a concept of ratios. So let's say you have two boxes. Let's say 10 feet by 6 feet by 5 feet. And then the larger box is 12 feet by 6 feet by 5 feet. What is the ratio of the volume of the larger box to the smaller box? So this is where they may try to test more than one concept. So you need to be able to figure out the volume, but you also need to be able to figure out the ratio. So if you haven't watched the video on ratios, you need to watch that. So what's the ratio of the volume of the larger box to the smaller box? And we'll say to the volume, I should have wrote that in there, of the smaller box. So what's the volume of the larger box? Length is 12, width is 6, height is 5. So the volume of the larger box is 360 cubic feet. This is the larger. The smaller box, length is 10, width is 6, height is 5. Put that in your calculator. 300 cubic feet. What's the ratio of this volume to this volume, of the larger to the smaller? Ratio is just essentially a fraction. So the ratio of the volume of the larger box, which was 360, to the volume of the smaller box, which is 300. You just write it as a fraction, and then you're going to do lowest terms. So if you don't know how to reduce a fraction to lowest terms, you need to watch that video. We'll first divide by each one by 10, so you get 36 over 30, and then we'll divide by 3, so you get 12 over 10, and then we'll divide by 2, so you get 6 over 5. So the answer to the question of what is the ratio of the volume of the larger box to the volume of the smaller box is 6 over 5. And again, knowing how to do the volume and do the ratio. So they may combine more than one concept, so I just wanted to give you an example of that.